Bit of an issue there. Hey folks.
Hello.
We're back. We'll start the show in a little bit. We're just testing audio. Can you turn your mic on better?
It is on.
Awesome.
It's probably the receiver.
No, it's on. They're all on.
Oh.
Hi to everybody in the chat room.
Hello, hello.
We have Tuna, we have Kirby, we have Raider, Sagnick, we have Sean.
What happened to my headphones?
Hello everybody. They're
upstairs.
Upstairs, sorry. Hello, hello. Testing, testing. Hello, hello. Uh-oh. Hello, hello. I think my mic is a little messed up. Testing, testing. Hello, hello. Yeah, it sounds like it's off again. Should have never turned it off.
What happened to the live show on Tuesday?
Hello, hello.
I think Phil was just doing a quick behind the scenes. The full video should be posted
Yeah.
soon. Stay tuned for tonight. He'll probably talk about it.
Hello, hello, hello.
For those of you that don't know what we're
Hello.
talking about, it was a really cool behind the scenes stream of the interview with NASA and Lamar. So be sure to check out the stream for any updates on that video.
Hello, hello, hello. Still broken. I'm so broken. Hello, hello. I'm still broken. So broken. Yeah, this happened earlier too. And I just kept fiddling with it until it started working. So I can't really do much about it. Real shame. Hello, hello.
Here's another real shame. Got these new 6mm nozzles.
Hello.
And I'm
Maybe that's
installing it, and the what's it called? The heating element broke.
Oh no.
So waiting to hear back on replacement for this. But
Why did it break? You pulled it or something?
no, I pushed it in to attach it. It freaking broke.
So it's really fragile.
Ugh. They used to use heat shrink on those. I don't know why they stopped doing that.
Yeah. Hey, is this better? No. It's like the variable audio or something. There's like an auto gain, which is really weird because this doesn't really have that option. I have 5 minutes to figure this out. Hello, hello. All right, that's a little bit better, but I'm gonna have to keep these headphones on. Yeah, I just lowered the sensitivity. Sensitivity should be decibels, like the gain. I should just name it gain. Okay, so maybe I'll have to do this again. My little mic thing here in front of my face. Yeah, is it turned down? Normally, we have it at the same sensitivity setting, and it's mine's a little bit different. Sometimes some of the weeks it's okay. Other weeks it's really sensitive. So I don't know.
We need another
Hello,
two-way.
Mark from Belgium in Europe.
Hello.
Learned a lot from your show. Really? Wow.
Yay.
Thank you for the comment.
That is why we do this.
Happy to help. Hey, look, it looks like it automatically kicked back now, so I'm going to turn the sensitivity back down to negative 30 decibels. All right, that's better. We fixed it. See, this is why we do the pre-show.
Such quality coming from a $1,500
Yeah.
set of audio
Yeah, well,
microphones.
90% of the time it's okay. Sorry about all that noise. I apologize. I'm hearing it too, so. Oh man. Let's see here. Right there. Here, I'm gonna just mute and then. Hello, hello. Okay, better. The moment feels like this, right? Hello, hello. Okay, that's a little bit better. Yeah. So the reason why we were out last week is we got Impact Windows installed across the house. It's 18 windows. So it was quite a bit of work. It was like 3 or 4 days of construction.
That should save us a lot of time, though, if and when the hurricanes come, we don't have to put up any more shutters.
Yeah,
so
yeah,
keep
a lot of different reasons, and saving on energy bills and kind of lowering the insurance because you have that benefit. So, unfortunately, we had to kind of shut everything down, and it kind of made production a little bit harder. But we managed, and things are great.
So we got 3 minutes.
Yeah. Real 3D printing sounds from around the studio.
Hopefully there's no clicking noises.
Hopefully.
Hopefully there's not.
You're kind of guaranteed to get clicking noise. There we go. Okie dokie. I think we're ready. Look. No delay. How quaint. Alright guys. We're going to put the blinds over and get ready to do the show. We'll be back in just a second. What's up, everybody? Welcome back to another 3D Hangouts. I'm Noe Pedro Ruiz, a designer here at Adafruit, and joining me every week, Mr. Pedro.
What's going on, everybody? I'm Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D printing projects featuring electronics from Adafruit.
That's right. This is a show where we combine 3D printing, DIY electronics to make inspirational projects for you folks. Thank you guys so much for joining us. We're live streaming on every Wednesday. Just a quick program. You know, we do this show live every Wednesday at 11 a.m. Let's get started with the show. Today's coupon code is CNC Wood. Get 10% off your order. If you order anything in the shop today, be sure to use the coupon code CNC Wood. Yeah. Hello, everybody in the chat room. Everybody up here is in the chat room. They are hanging out with us live, and it's on YouTube. We're also streaming on Facebook, too. So hello, everybody in Facebook world.
Quick shout out to everybody in the chat room. Simone is in the house. What's going on? Simon.
We want to say Simone, but Simon.
Galactic 3D, Jim 2386, Isaac, Ryder, Greg.
Thank you, Greg, for the comment on the phone a feather. I will get on that. That was one of the things I didn't test.
All the way from Belgium, we got Mark, we got Chimo, Tuna. Thank y'all for joining us every week. Yeah, so let's get started with the stuff. If you order $100 more, we do this every week. You get free shipping in US, in the States here. So that's cool. You spend more money, you get something free. Shipping. One slide that's not in there, we now have DHL shipping as well.
Folks in Canada. We have same-day delivery stuff in New York City. Certain zip codes apply. Check out the site for more details on that. We still have a newsletter. If you want extra content and things on a daily basis, you can do that. Go to adafruitdaily.com, biohacking, CircuitPython.
And our newest edition, CircuitPython, being headed up by Scott and Tony D.
Okay, good stuff. This week's project, it just launched at an hour ago. More CNC, more wood, and a little bit of acrylic. This is a CNC milled case for the Raspberry Pi 3. It's a two-piece enclosure with a little bit of extra acrylic pieces to kind of make it nice and pretty. The main kind of thing, since we didn't do a show last week, let me show you. Last week's project was CNC milled. This is the Joy Bonnet with the Raspberry Pi Zero. And the one thing I wanted to do with this differently is take a look at these cutouts, right? These cutouts are kind of big. When you're using a 3-axis CNC mill, you kind of can't make these undercuts or overhangs, right? So what I end up doing is having to start the opening from the top of the case all the way down. So these are two pieces, and you can see that the cut is all the way from the top. So one way to kind of combat that was to make this kind of interesting little faceplate thing that is milled flat on the bed, like this, oriented this way. This way you can kind of get these nice and pretty holes and kind of play with different materials you can see in there. So that was pretty neat. Another thing is this is all friction fitted. I haven't done a case that's friction fitted before, so I had to kind of guesstimate what the tolerances would be. For a 3D print, this would probably be a tolerance of like 0.2 or 0.3 of a millimeter, sometimes even 0.4. But for CNC milling, 0.1 was the kind of offset that I had on this inner lip. This little inner lip here, it kind of slides into the inner wall of this case. So that's kind of how the two are held together. I really didn't want to use screws to hold the two together. A lot of the times when you want to CNC something and you need two halves to fit together, you end up using these long screws to kind of fit and sandwich the two together. But depending on your application, I'm not going to be moving this around too much. So that is why I wanted to try out this kind of lip method where it snaps into the second half of the case. The other thing was these little things here. I typically wouldn't add this for a 3D print, but I thought I would give it a shot with this wood. It seemed to work out well. Another thing that didn't work out was this tolerances here. So there was a little bit of a tolerance thing. There's a kind of a recessed area here. So I ended up using E6000 glue to just glue these two pieces together. So that ended up working fine. This is done with an engraving bit, 80-degree chamfer thing, and it's just an 1/8 of an inch piece of acrylic. So that's how that works. So I put together a guide on kind of some of the things that I learned on it. So if I go switch to the guide, you can see just a little bit. I'll kind of walk through it just very quickly. So a little bit of the design stuff. One thing I really wanted to do was to be able to use my biggest tool to kind of mill out the most of the material. And the tool is 1/8 of an inch, right? So it's like 3.7 millimeters of a radius. So when you're designing your case, you need to be able to actually cut in between things. So an example here is that standoff that you see. Can you see that?
Yeah.
The standoff there, I had to increase the overall dimension of the case so that I can actually get in there and mill in between those areas. So I did want to have like a really, really thin and slim case, but you can't get smaller than the tool bit. So that's why I kind of did that. Let's see, the faceplate was kind of the interesting thing. I used a different size bit for that one. Not much there. The friction fitting stuff worked out well with that 0.01 offset as I was talking about. Those little finger things are kind of interesting as well. I normally wouldn't do that with a 3D print, but I gave it a shot with CNC and it seemed to work out okay. So I got the STLs in the Fusion 360 source file if you guys want to download that. If you want to 3D print it, I don't think the tolerances are going to work out, especially since the offset isn't that, it's not tested for 3D printing, so I don't think it'll 3D print. So that's why I gave out the 360 file, so you can quickly modify that offset. Milling. So one of the things that were probably obvious, in hindsight, is that obviously you want to pick a material that is kind of already the size of your stock. So for the bottom half, I used this hard maple, and that was half of an inch, so that's 13 millimeters. The case itself, well, at least the bottom of the case is 10 millimeters, so you're only removing 3 millimeters, but I thought I would buy some nice oak wood, and I should have got the thinner version of it because the 3/4 of an inch is 19 millimeters, so I ended up just facing the material for 34 minutes. So half an hour,
Just to make everything nice and level.
Just to, yeah.
And that's only one side
It's
of
only
it.
one side. One thing I'm going to do moving forward is to space both the top and the bottom, or just bust out the hand plane and plane that thing down a little bit better. So
Wow,
those
this
are the two
takes
options.
so much more time than 3D printing.
Yeah, because the first thing you got to do is prep your material, cut it down to size,
Make sure
level
that
it.
the tool path is going in the correct
Yeah.
way and that it's not crashing into anything.
Yeah, exactly.
And then right afterwards, you gotta clean up,
What?
which is almost the same as 3D
yeah,
printing.
the cleanup. Yeah, there's quite a bit of swarf and stuff that you have to clean up. One thing that I thought I'd mention is machining boundary. So when you're setting up your cam operations, you can tell the machine and the operation where to cut and what not to cut. So sometimes it doesn't make sense to cut everything, especially the excess material that isn't a part of your design. So when you set the machining boundary, you can pick a surface, or you can pick an outline. And for this specific project, limiting the machining boundary to just the inside of the case, not the outside. I said it wrong in the video, but in the inside of the case, I prevented it from milling out every little thing. So that worked out well. Another thing is to talk about heights. So specifying where to start cutting is an important thing. You could also use a reset machining, which will look at the last operation and then be smart and say, okay, I don't need to mill that away because that's already gone. So those are two options. Stock to leave is another thing I thought I'd kind of worth mentioning. If you have that turned on, it won't get you those fine cuts. So if you have something that is very tolerant, specific, make sure you turn that option off. That's normally for something when you're kind of securing or clamping your stock to the spoil board. You want to have that so that your part doesn't come free from that vise, because you need to hold it in place at all times. So for me, on the other mill, I tend to just have everything secured down with tape, so I don't have to worry about that. But it was one of those things where I was like, why isn't this cutout being the right size? And it was because I had stock to leave option turned on. And that's something that's a part of contours and 2D pockets, 3D pockets, that type of thing. Post-processing, I really didn't do much other than sanding a lot, so there was a lot of cleanup to do. I still have yet to learn on how to do final finishing techniques within Fusion to kind of fine-tune and
Meaning
carve
like
out
putting
all those burrs, because there's a lot of burrs. This is wood that we're working with, so it tends to kind of leave burrs. So just a lot of sanding. So I ended up getting like a little engraving kit, sanding bits for my Dremel tool, which helped out a lot. Filing tools are all nice and great, but the Dremel tool saved me a lot of time. Assembling is very, very straightforward. I got lucky with the faceplate that seemed to just hold tight with a nice tolerance. I guess tolerances work out better vertically than horizontally. Case in point, the top plate for the window just fell right out, so I had to use glue. I like E6000 a lot because it doesn't haze, so it doesn't decolorize your material, and it's flexible, so it works for flexible type things. It takes a little bit to dry, but in this case, it dried out really quick. I guess because acrylic and wood dry out really quick. Yeah, I got lucky with the two halves as well. That 0.1 millimeter offset really helped out, and that was okay. One thing with wood, it's easy to sand, but it's also easy to take out too much material. Yeah. So you got to be careful with that. But that's it. I don't have any plans for a future project. This is just something that was like itching to try out. I really wanted to make that faceplate concept where it was just like a two-piece thing. So that seemed to work out okay. Yeah. Yeah, maybe some metal next time. I don't have any plans for the next CNC project, so we'll see. If you guys have any cool project ideas, let me know. I'd love to hear about them.
Yeah, so real quick question in the comments, someone is asking, what is the cheapest CNC that is worth getting? So we were actually taking a look at this, got an email about, what was it? Was it the Carvey?
So the Other Mill Pro is probably the most expensive one at $3,300.
There's reasoning behind
it. You have really fine pitch. You have a really, really fast spindle at 26,000 RPM, so you can cut through acrylic really, really nice. You can cut PCBs.
That's what the main focus of this
I think the main
is.
thing is software. So it has integrated
Yes.
Eagle support, integrated Gerber support. So if you're milling a PCB, you don't have to worry about kind of reworking your Gerber files to work on your CNC mill. The Carvey is another good option. It's got a bigger build volume. It's $2,500.
The software looks pretty good.
Yeah, the software looks pretty good. The spindle, though, maxes out at 12,000 RPMs. It uses the same collet. It's the ER11 collet, so you can kind of use the same tools. It's a good option. If you don't want to do PCBs with fine pitch, you can try this out. Supports G-code. Another one, this is the thing Pedro was talking about. This is the one from Carbide 3D. This is the Nomad, fully assembled. I think it's fully assembled. I sure hope so.
I would
for
not be
2,500
surprised
bucks.
if it's not.
I would be surprised if it yeah. It
No,
doesn't
ready
say-
to run out of the box.
Great. So it has mesh cam, so you can turn your STLs right into your G code, which is kind of nice. And I think the RPMs max out at 10,000 RPM, but it's got a pretty decent build size. I think it's 8 by 8 by 3, so it can do some nice depth, 3 inches.
Yeah,
And
again,
fully enclosed, nice spoiled board. It has some nice, built-in probing, so it'll probe itself every time. I think the Carvey does the same. But somebody in the chat, in the YouTube was like openbuilds.com. So if you are if you really like building your own machines, check out Open Builds, and you can build your own for I don't know, $100 or so. The Shapeoko is another thing, but I'm not sure if I could recommend that. Kirby has one, and I think Phil B might have had one, but the instructions, the assembly instructions are a little bit iffy, so I'm not sure if I can recommend that.
I think Todd had one as well, and he had to do a lot of workarounds to get
He
it
did?
to get assembled.
Yeah,
Yeah,
I remember he had an X-Carve too. So
yes,
maybe that's what it was.
I think that's what I'm talking about. The X-Carve.
Okay, yeah. Yeah, the kit version, because X-Carve comes in a kit, or I think fully assembled. I'm not sure. But anyway, a lot of options out there. There you go. Okay.
Nice little tutorial for anybody wanting to make that transition from 3D printing into CNC.
Yeah, this is more like a book report than like a step-by-step instructions on how to set it up.
All of the paths are going to be different for different machines, so
I think so, yeah, especially for different
Nice.
stock.
Yes.
So my G-code's not going to work with you could offset it, but I'm not sure if your software can offset it. So, hey, options
very
out there.
interesting.
Yeah. Cool. So that's this week's project. Hope you guys like it.
And last week's too, just in case, just because we were gone, we just wanted to mention the Joy Bonnet. We have a Raspberry Pi Zero on the inside.
Yep.
So just hook up a monitor and you
Yeah.
are ready to start
All in
playing
one
all those
console
retro
controller
games.
thing,
Yeah,
which is pretty cool.
super nice.
Yeah.
It looks pretty tiny, and the buttons are laid out pretty nice. So it's not so tiny that you're going to be mashing 2 buttons at the same time. So definitely check it
Depends
out.
on your hands. If you have Wreck-It Ralph hands, you might have a little bit of issue. But I have a project for you guys. If you do have Wreck-It Ralph hands, check out the community makes later in the show. It's pretty cool.
Might have to do with jumbo-sized controllers, huh?
Yeah.
And remember, you can always use the discount code. This week it's CNC Wood. They get 10% off your order. You can get Raspberry Pis, the Joy Bonnets, all of the cool electronics to bring your projects to life.
Yes. Well said, Pedro. Well said. All right. We're working on a lot of different projects. Pedro, did you want to
Yeah, so
start with
this
one?
week-
I really like your project. This was fun.
So getting finished with my Guardian Sword from Breath of...
Fresh Air, Breath of the Wild,
Yeah.
Zelda, Nintendo Switch.
So it's I forgot what the length is. It's about the same size as the Gunblade sword, so it's pretty big. Let me step back so you can fully see. And let me drop down the exposure on that. So we got the blue blade and then the orange
It's real.
sort of color that's going down here on the handle side of that. And I just added the details for that. And the cool thing about this is the Halo sword that I worked on, I think last year, everything was held together using glue.
Yep.
So if you wanted to do any maintenance on that, it was going to be obviously a little bit more difficult to pull that apart.
It's permanently shut. I
Yeah.
can't get to it.
This
Yeah.
time I opted out for doing everything with screws. So they're M2 screws. Now they're 12 millimeters in length.
So they're pretty big.
Yeah, the whole thickness of the blade is, what did I say, 24 millimeters thick? So it's not too thick,
24, yeah.
but you are going to need some pretty long screws for that. And you can barely tell just how small they are.
Yeah.
that ended up working really well instead of having to glue all the pieces together.
Yeah.
So we're printing this on the Type A machines, actually printing another one to send over to the office. So you are going to need a pretty big build plate if you want to print it at the size that I cut it at.
Yeah.
But of course you can always cut this up even smaller for your printer bed. And we'll talk about the electronics and all that, but you have access to your port to reprogram or to charge it up. So we have a Trinket LiPo backpack battery inside here to do the recharging, and we're using the 2200 milliamp cylindrical battery on there. Other things, it's just a Trinket and the mini skinny neopixels, the medium density. So there is 91 neopixels inside here. 93 neopixels inside here.
Yeah, bit of an odd number, but it kind of wraps around back in there.
Yeah.
So we did some pretty nifty stuff, not too nifty, but very basic stuff in the code that just kind of say, hey, specify a specific range of neopixels, and then just use a for loop to say, you know, every color in that range be a certain color. So
so from going down, it's going to turn orange, and then up and around, it's going to be that nice blue. So there isn't really any animations in the game for that, so it just turns on.
We blew out the camera.
Oh, wow. It's too bright.
We blew it up.
Oh, you hear that clicking? This has been a nightmare to print.
Yeah, so
it's so big.
One of the most challenging things with large prints is to print them without failing. A lot of different things happen.
Yeah, so we'll talk about this more. I think we'll release it next week or the week after.
Probably the week after.
Probably the week after.
See.
But
we're just still working to figure that out.
Yeah. But it's close. I already shot all of the assembly and the printing for that. So soon we'll get that out.
Very large.
And then the other thing that I've been working on is a mini desktop PC. So I think I showed this off 2 weeks ago. It is a rework of the 7-inch display case with a little kangaroo full-sized PC on here. We have some brackets holding it in place, and the thing that's making this pretty compact are these new ribbon cable connector HDMI cables, which are just a PCB. So instead of having a big honkin' HDMI cable to connect this, we have a nice slim little, pretty discreet looking HDMI connector that's going from the screen to the mini PC. And then we just have the brackets holding it in place. We have spots for the 1/4-20 for connecting it to a tripod. And the whole reason, it's very utilitarian in terms of why I made this. Every time there's a new firmware upgrade for any of the printers, not all the software works on a Mac, so I can't just haul my laptop over to it. So it's a lot more better to just use a full-blown PC for those type of tasks.
I believe you can install Fusion 360 on this guy, can't you?
Yeah, so for any quick edits, and even if you wanted to give this away like as a gift for your parents, their PC is however many years old, you can just give them an all-in-one solution that they can even hook up to the TV or something like that.
Cool.
And we have a full-blown PC. The Kangaroo all-in-one mini PC has a built-in battery, so there's a 4-hour life on there, and the screen has its own battery inside there that should last about 2 hours. I have a 2,000 milliamp hour battery on there, but there is definitely enough room to fit an even bigger battery inside there, which is probably what I'm going to do, just to give it, to take advantage of the extra space that's in there. So, oh yeah, and of course, like I said, it is a rework, so all of the attachments for hooking up all of the mounting, and then of course, instead of using screws everywhere like we did on the last one, we're using all of the very fancy nubs that Noe started using on all those. So very easy to disassemble. Take a look at that. So everything is just snap fit together. It has a very nice tight tolerance on that. So they can all stick inside there without having to use any screws.
Add nubs to all the things.
Yes,
that's good.
Well, I couldn't add it to the sword. I really wanted to add nubs to the sword, but there's just way too many curves on that.
It's just easier to use screws.
Yeah.
It really depends on the project.
If it's a nice, just box, it'll work perfectly for that. But we'll talk about this week afterward.
Yeah.
After the sword. So really close.
Did you want to highlight the the
what?
HDMI connectors, like show them off individually?
Oh yeah, we can do that.
right,
So
real
we
quick.
showed this at our meeting last week, and Lamar is looking at getting some samples so we could potentially stock these in the
Yeah.
store because just so handy. Take a look at what these guys look
These
like.
are really great. If you're doing a project that needs a display with HDMI connectors and you need it to be embedded, these are really nice options. These
Yeah.
are little PCBs that have the HDMI connector soldered onto it. Different orientations. You can have it up, down, right angled, or straight out. They're really nice because they have really, really thin profiles, and the cables are these kind of
That is
ribbon cables
the
that
coolest
have
thing
a little
about
bit
these.
of a little bit of a fabric to them. They're very, very skinny. Like show them the thinness of
So
it.
that's the cool thing about these is these little latches open up and then you can attach whatever size ribbon cable that you want on there. You just insert like that and then clamp down like that.
Yep. So these are great for even like FPV goggles or a portable display that you need to be like hooked up to some other device with a really slim profile. Kind of monitors for cameras, that type of stuff. Works really well with this.
So we'll take a look at it, getting these, and I think we already mentioned these come in different orientations, 90 degree up, 90 degree down.
Mini C,
regular
HDMI connector types.
It's type A, type B, type
Yeah.
C.
Because last week or the week before, I experimented with just cutting an existing cable and then like
That's so
chipping
many
away
wires,
all that excess.
That'd have to
rubber.
be all of that right there that
Yeah.
you would have to solder
very
on. Can't even
small
see
pitch.
it. Yeah, it's like 0.5
Yeah.
is the pitch on that. But yeah, we'll take a look at these. Hopefully we'll get these in the store because they're so handy for all of the small little projects where you want to fit inside there instead of cutting up all the HDMI cables.
The Isaac has a good point. Like, isn't it fragile? Won't it break? They're surprisingly pretty.
Yeah,
tough.
I've bent these.
It's a bit of surface mounting plus through hole, so you can so you have some pretty good mechanical strength.
Yeah, so I pulled on a couple of these
Yeah.
by mistake and I bent
did
them.
too. You bent-
And
which one did
they,
you bent?
this one right here that I'm still using, yeah.
Oh, you bent it.
So you can see that.
When I was
You can do a
testing
nice
it
little
with the
bend on
Canon
that.
5D in a monitor, I accidentally tugged on the cable and the latch just popped open. It didn't break either.
Yeah.
It didn't break. So
Yeah, same thing with this one.
we'll
I
do
think
some
I,
more strain tests and things, but
no, they're pretty
if it's an
solid.
embedded project, you're not going to be touching it, right?
Yeah.
So, but for other projects, yeah,
Mm-hmm.
we want to do a little bit more testing. Real quick, Raider was asking, what's up with the clicking? What does that mean?
So it just hit me. I think I forgot to add more thermal compound on that new extruder.
So it's cooling down too much, or is it
Yeah.
enough?
It's not heat ample enough yet. So I
The
will
filament's
have to.
cooling down, and it's not.
It's definitely not a leveling
hot
issue
enough.
because I've made sure that it's not so squished into the bed.
Yeah, that's another reason.
It's
yeah.
compound. I need to add to that.
Yeah. So the noise clicking is the actual drive gear, like skipping.
No, it's trying to push
As
down,
it's
but it
trying to
can't
push-
because it's
yeah.
not hot enough.
Yeah.
So I'll take a look at that after the show.
It's not clicking, but yeah.
Yeah.
Maybe the heat cut.
Like I said, this
never.
it's one of those things that you finish one complete build and it's like, oh yay,
Yeah.
let me just print another one, and it just keeps failing on every part.
Yeah.
So goes having to do a weekly project.
Yeah.
All right, cool. Let's take a look at this week's layer by layer. I
Yeah,
think you have one
I
on
do.
the Joy Bonnet.
I do. So I'm going to publish that later today, probably around 3 p.m. Eastern time. But I wanted to show you guys real quick what got me excited about this one. So let's go ahead and flip to this guy and then go over here. So this is the Joy Bonnet. In this week's Vision 360 tutorial, I show you how to assemble this bottom piece here for the Raspberry Pi. But one thing I really wanted to show you guys is kind of how adaptive this design can be. So let's take an example that these two pieces are pretty flush together, but let's say we don't want them to be flush. Let's say we want to use the regular headers that aren't low profile. So that means the distance between these boards have to be a little bit bigger, right? So if I go in here to my captured position, I can adjust this, right? So I can say the Joy Bonnet is actually a little bit more elevated. Maybe it's 5 millimeters. When I hit OK, normally what we would do if you kind of design it in a different way, when you hit OK, you will have to kind of update your extrusions. But in this case, when I hit update, hopefully everything gets updated. Look at that. A little bit different, but you can see kind of what's happening here. The cutouts are kind of adaptive. They're kind of growing with this bottom piece here in the surface. So the way that's happening is I'm using a construction plane to do that. So if we go over here into this little construction plane, everything's being derived from this construction plane. Can't seem to edit it, so let me hit edit feature. So instead of having to readjust your surfaces or using the push and pull command to push your things out, I can just update this construction plane, the offset for it, and then things kind of automatically get updated because I'm drawing on top of this construction plane. So I'm gonna change this to like 5, and you can see that I just moved 5. Not only that, but it's parametric in the sense that if I do section analysis, you can see the standoffs have even updated. So those are the corner standoffs back there. They have automatically updated, and I don't have to do too much. So really, really quick way to modify your design and not have to do too much work. Because a lot of times I do a lot of changes, and I have to start designing it in a way where it's adaptive to those changes. So I'm really excited about that. I'm starting to use construction planes more and more these days because they work really well. Of course, using your extrusions when you're extruding stuff, instead of adding a distance, let me see where I do that.
Which is typically what I do. I'm
Yeah.
like, okay, offset.
So you see that
however
extrusion
many.
here, right? It's not actually a number. It's actually saying
I mean,
to
there is a
an
number
object.
behind it, but
Right, but the number is adaptive. It'll always update. It'll always say whenever this surface is changed, go with it.
with
So
it,
that's
yeah.
why it's updating like that. So let me just undo all that. Pretty cool. I'm really excited about that. I'll be doing more of that type of stuff. So hopefully that helps anybody out who's working on a project that is kind of, you're designing 4 changes in mind.
Yeah.
If you don't need that, then you don't have to design
Well,
this
whether you're
way.
printing, you are definitely going to need it somewhere down the road to change
Yeah, for
something.
tolerance testing, it's a great thing, I think. But it might be a little bit different. But I talk more about that in the layer by layer. But that's just one of the quick things I just wanted to show off, that type of thing. So
Nice tip.
check it out. Thanks. That was layer by layer. Again, later today. Let's do shop talk.
Our very own John Park has come out with a super
Super awesome project. If you're looking for a way to remotely control things, and Bluetooth or Wi-Fi is kind of not an optional, especially for like theaters or somewhere where there's a bunch of
Wi-Fi and cell phones,
stuff.
yeah.
Check this out. So this is John Park's latest guide. He actually took the design we put together for the trellis to make an instrument, a MIDI instrument.
buttons.
He took that and turned it into a general purpose kind of remote box that can trigger different things. So he has a lot of different samples. There's a lot of sample code as well that you can use. It uses the radio feather wings and the radio feathers to output signals that are in a certain spectrum. I think it's 900 megahertz or so.
And you can get those at different spectrums as well. So these are all the LoRa. Is it the LoRa ones?
It is the M0 RFM69HC packet radio.
There you go.
So you can do different stuff. Antenna, all the STL files, all the instructions on how to build one is all here. John Park did a great job on the assembly instructions. So everything's really thorough and thought out. Circuit diagrams galore.
And of course,
Great
the
use of the trellis
updated designs
to do
too.
remote triggers. Yeah, updated design as well. So he added the kind of little switch holders and stuff like that. So really cool. I put this originally designed as a 1-2-3 design, so it didn't have much parametric options back then.
Yeah.
But you can easily import this now into Fusion 360 and go to town with it. Like those little tabs there would have added a draft and kind of.
That's really the most difficult thing about some of the older projects that we're reworking is because they were all designed in 1-2-3D. They're not editable in terms of adding the dimensions on there. But
once
they're
you get
pretty
them into
easy.
Fusion, you can.
They're pretty easy to work with
Yeah.
afterwards, yeah.
Yeah.
It's just figuring out where all the, because of the way that we used to design in 1-2-3D, there was like, you know, the version 1, 2, 3 before we did a union or a boolean on it and all that.
Yeah, so great guide. Wow, I love that diagram. I don't even do
it's
that
cool.
type of diagram.
It's a nice way to do that.
I think that's Rhino 3D. I gotta ask him.
Yeah, no.
Or is it Fusion? I don't remember. Nice little battery holder too.
Yeah,
Pretty cool.
that's
Use
a
some
nice
support
way to do
materials
that.
there. Yeah, nice way to do it. So a lot of great little tips you can take away from this, even if you don't want to build this project. You can still kind of walk through it and see.
And it could be any project too.
Yeah.
That'll give you walk away with some sort of really good tips.
Mm-hmm.
This
Pretty
is
cool.
definitely one of them.
Pretty cool. Great use of those M2 screws,
Yeah.
M2.5 screws. Cool. I could be looking at this all day. It's a nice, long, lengthy guide. So get your cup of coffee and just read the John Park. Cool. So check that out. That is, of course, at learn.adafruit.com, right on the homepage there.
Next up, we got, we were talking about the Supersoft HDMI cables. You wanted to recap on the failed Ninjaflex wheel.
Oh, yes.
Experiments?
I completely forgot about this. So a couple weeks ago, I guess 2 weeks ago, I really had this, really wanted to experiment with making a 3D printed wheel for my longboard. So I wanted to use Ninjaflex and ABS to make this longboard wheel. So this was 3D printed. This red piece here is ABS. The black is Ninjaflex. This is a fully Ninjaflex tire wheel, just kind of prototyping and playing with the different shape and trying to get the tolerances right. This obviously doesn't work because it's too floppy. So as you skate on it, it just kind of flops around. It's like a flat tire, right? This version the tolerances worked out okay. I could skate on it, but there wasn't enough Ninjaflex, so it was really, really kind of a hard ride. Didn't feel really good. So then I figured, oh, just increase this and then decrease this. So this is what I came up with. This is not dual extruded. This is printed in 2 separate pieces, and they're joined together, not with glue, but with a little kind of nub thing. So there's a little key inside there. I can't take it out, so that's one of the things that once you install it, you can't take it out again. But the main problem here is that none of these layers bonded with each other, so they're all kind of loose. When it was printing, it looked like it was gonna be fused together. The only parts that fused together was this Z seam here, so the seam where everything's kind of looping on the perimeters here. So this is all perimeters. It's like 4 shells or something crazy, like maybe 8 or 10 shells. So there's no infill, it's just all perimeters. That didn't work well. So I kind of shelved this idea. So skating on this doesn't work well. It tends to fold in on itself. And yeah, these parts just didn't happen well. But this ABS part is definitely strong enough. This is all perimeters too. So it's like 100% infill in a way, but it's all perimeters. So it's a nice clean tool path of just concentric patterns over and over and over again. But this was a fail in terms of like, does it actually work? No, not really. It fits, but the Ninjaflex just didn't, I just couldn't get these layers to fuse. So I could try messing with that, but I probably won't. I moved on to a separate project. Instead of wheels, I am now doing a truck riser, which I'll talk about next week. If you follow me on Instagram, you can kind of see what I'm kind of testing there. But yep.
Nice integrated way of adding lights to your night rides.
Yeah, I think that was a better idea because there wasn't really any electronics here. It was just more of like material properties and seeing if that works.
Although some of the recommendations were to make a 3D print to make a mold to then
Yes.
resin cast
Yes.
LEDs inside of there.
Yes. Could be a cool option.
That'd be cool, yeah.
Yeah.
Maybe we'll do it down the road, but
Yeah, I
for
think
now-
another option, though, for the truck rides, I really like that idea. And the end goal is to send one to Braille Skateboard YouTube channel. So
Yeah,
they
that'd
can
be
skate
nice.
it or
Break
we
it.
make it, we skate it,
You make it, I break it.
and they'll break it on the first try. Can you imagine that? The truck's like braking, landing on the 500 milliamp
Oh,
LiPo.
God, that
and
would
then
not be
it's just
cool.
like injections, just like skating, and then pew, like
I
that.
exploded
It's a
it.
fun- Yeah,
First
right?
try.
First try, it exploded. Yeah. I know Fetty would break it. Anyway, under extrusion on that.
For the wheel, I think
I
it
don't think
might
so.
need
Those
some
layers are. If you look at the layers on this
zigzagging.
side, that's great layer binding. There's no under extrusion here.
Yeah,
It
it's
looks really,
the
really nice.
it's
Look
the
at that.
distance between the layers.
Yeah, it's the
connected on that.
perimeters.
Perimeter, yeah.
It's like the extrusion width just isn't enough.
Just
But
too thin.
as you start increasing it, your tool paths start changing. So it's
Yeah.
like, oh man, I really want these concentric patterns to,
Yep.
to kind of lighten the load on printing. But maybe that's the wrong approach. Maybe
Yeah.
it really does have to go back and forth. Or is our audio okay?
I was just trying to
Salud.
make myself. Excuse me.
Yeah,
Ooh, listen to that click.
more clicks.
Woo.
Was that it for Shop Talk, I think?
Let's see. Yep. It's time to move on to this week's Community Makes.
Actually, what about this guy?
That's
was-
Community Makes.
Oh, It's a bit of a shock.
So last week, Time-Lapse Tuesday, well, it's a community make.
Yeah, it is.
Was this really cool remix of the monster truck, this time with a Jeep version in it. And the wheels are these really cool bearings.
Yeah, this is on
Spin around.
Thingiverse. If you want to check it out, it is by Bill Line.
Yeah, so he took a couple of parts from Emmett's bearing design,
Yeah, gear
and then
bearings.
Jack's the suspension. So we taking a look at. Where's our
looking at
camera?
that.
Oh, there we are.
Overhead.
Yeah, so this is a really cool way of making springs on your 3D prints with a rigid material. You just use this little zigzag and you're able to have these bend and fold. So we have the suspension that can go up and down and then left and right.
Pretty neat.
And then the tires were printed with Cheetah Ninjaflex on the Ultimaker 3. I just used the default profiles that they have in the new Cura 2.5, and that worked out really well. And then I really like the detail at only 0.2 millimeter layer height that we were able to get on all these. I think the funniest thing is the spare tire that would totally not fit on there, but lots of cool little designs inside for the seat and of course the steering wheel and all that. I did have to use support material for this. And then some people were asking how we got the bearings to print. So I did have to do a horizontal compensation, which means that I had to shrink the size of the gears. Inside Simplify 3D, that'll do that for you. It'll take the outer shell of that and sort of shrink it. So I had to do a negative 1.2 millimeters for that, and that allowed the bearings to spin very well.
That's a really big value.
1.2, yeah.
That's crazy.
I know. Otherwise, all of these will fuse together. Even at the negative 1.2, they did fuse a little bit. I had to use a plier, hold on to one of the bearings, and then sort of push it down or up to get it loose from some of the stringing that happens with printing. And that worked out really well. So very awesome job on that.
Sometimes they still get stuck, and that's just because of the kind of orientations of the
Yeah,
tires, I guess.
yeah.
So it's not
They
really like
could definitely get
100%
stuck.
free spinning.
Well, this one, yeah, especially, I think I used a 1.3 on this, so they're actually smaller.
Yeah. I remember
and
you added
they
it too
skipped.
much, and they fell out.
Yeah.
Yeah.
It took quite a bit of trial and error to get this to work, just because the tolerances on printers are so different. But, yep, works out if you know what your offset is for that.
Yeah, it's going to vary from printer to printer.
Yeah.
Filament to filament.
I should print them all at the 1.2. This one's 1.3, so it's smaller, it misses a track, and then grinds and gets stuck up against one of the other bearings.
It was interesting, though. I like that you printed a version where they fell out, because then you can actually see inside and see how the worm gears are kind of designed. So the reason why they're not being pushed out is that there's a little bit of a V shape that keeps them contained inside of the kind of main planetary system here.
Yeah.
So make a fidget spinner. Cool. All right. Again, if you want to check that out, you want to print it yourself, or have somebody print it for you, you can check it out. It's on Thingiverse. We'll have it linked below, and I think it was shared last week.
Yeah, thing 2255-26-1.
Oh, cool. So check that out.
And then
All right.
this week's Time-Lapse Tuesday was this cross-section of a face.
Let's see where it is here. This one. Yeah, this is a eyeglass company. They make glasses, I suppose.
Yeah, so this is Vinylized Eyewear. They make frames out of recycled records, vinyl.
Yeah.
Vinyl records.
That's awesome.
Really cool. So they're using this as a display in some of their stores.
Yeah.
It's really cool use of 3D printing.
Yeah, they have different people.
Yeah, different faces. Somebody asked if this was the Nefertiti face. And
Yeah, like a
it's-
cross section of Nefertiti. Nope.
Yeah, this is somebody named Betty.
There's a Betty right here. So you can pick your kind of face shape that you want.
And what's
like
cool
this
about
one.
this is that you can use these as just holding on to your glasses, and as we showed in the video, using like the Google Glass, or oh my god, it's too bright. Woo, let's just show it over here. Looks way better.
You're drunk overhead. Go home, man.
I know. So we have a nice little hook on the back, so you can mount these to a wall, or as they show in their video, they just put it on, like inside of a brick wall. And it has the perfect size of a head, so you can hold whatever glasses, sunglasses,
kind of
whatever.
eerie.
Yeah, I know.
It's kind
What's
of
cool is that the glasses fit on there.
Yeah.
Have the ears all nice on there. So a nice little way to, nice little, I guess during like Halloween or something, it'd be nice to have all those glasses on there.
Sure.
Have it talk. So check them out. The Thingiverse file will be linked in the
Fix
description.
the overhead, yay.
Yay,
It's a
there
big
you go.
print anyway. How long did it take to print?
I think it took about 3 hours. It's noted in the time-lapse Tuesday video though.
0.2 layer height?
This is 0.4 layer height, and we're
Big
using a 0.6 millimeter nozzle on the
Nice.
Sigma BCN 3D.
Yeah, can't even see the layer lines, kind of.
You can see them. I mean, it's this camera.
Yeah, sorry.
Definitely see them
That's
there.
weird.
It's pretty big. Again, nice little creative way of making eyewear displays.
Check it out, Thingiverse. There it is. Looking rad.
And I think we can jump over to this week's Q&A.
I'm still doing the things. All right,
Oh,
so I just
sorry.
got some really quick projects. This one's from AT Makers, Bill Binko. Put together this kind of watch linkage design for mounting an eye gaze. So I'm just going to read the comment. This is really nice. This mount holds a Tobii EyeX eye gaze camera directly under the monitor and maintains its orientation. Mounting an eye gaze device correctly is critical for those who use it to control their computers and communicate. One challenge is the monitor sometimes must be rotated to the user's orientation. So let's say they're in a bed or a wheelchair. So this is great. This is a great way to kind of get all the orientations for anyone who needs assistive tech. So great job, AT Makers, Bill Binko. Definitely will share this on the blog, and there's a nice video on kind of the walkthrough of it, so you can check that out. Next up, this is a giant Super Nintendo, big Nintendo. It's just a really, really big joystick thing. It's awesome.
So cool.
Yeah, so here's the
Wow.
normal one, here's the big one. If you have Wreck-It Ralph hands, this is for you.
I like the joystick
Yeah.
added to the D-pad
I
there.
think there's enough room in there for a Raspberry Pi. There isn't a Raspberry Pi in there currently, but you could probably put one in there.
Oh yeah,
Big
definitely.
print. Parts printed separately and glued together, probably.
Wow.
Check
Oh,
it
he's
out.
even got the 3D printed NES on there.
Yep.
Very cool.
Angry Balloon on Thingiverse made a nice Python script to make like you can
Brightness
save like
control.
50% of your battery life on the PiGRRL 0 by turning the screen at 20% brightness or even 50%. So you can use one of the buttons to control the backlighting. So that's awesome. So the Python script is available, and this is a great little kind of upgrade modification to the PiGRRL 0. I love seeing these things. Great stuff. Somebody 3D printed the joint bonnet.
Ooh.
Yeah, this person here on Thingiverse 3D printed joint bonnet on the ANET A8, which is a clone of the DIY kit of the Prusa style printer.
Now,
Looks
did they
pretty
say
nice.
if there was any offsets that needed to be adjusted?
Nope, works perfect. Thanks.
Wow.
Nope,
Very
that's
cool.
because there's no real friction fit stuff. It's all you use screws to secure them. So
Okay.
worked out
All
well.
right, there you go. You can print it out yourself.
Yeah, first try.
Very cool.
Cool. This is great. This is from Sophistically Advanced. Great YouTube channel.
Yes.
Lovely person. He made this. This is awesome. 3D printed PLA. This kind of spider grip thing. Very, very awesome. Watch the video if you haven't already. He actually tested it and it worked for a little bit. Look at this. Like this is holding his weight. This is PLA, dude. This is
Oh.
PLA. It held his weight for a little bit. He changed the design and stuff like that. And he's printing it on his Flash Forge. Kind of.
Oh,
There you go.
CTC, yeah.
Yeah.
A Replicator 1 clone.
Love this guy's stuff, man. He does some great stuff. He did the Thor, the real Thor, real life Thor hammer. Great content.
Yeah, it was surprising too when you were using all of the PLA on the truck risers on how I was able to keep from breaking with just PLA.
Can't play too much. We'll get. He's dressed up like Spider-Man. It's funny. This is awesome. This is from Walter. I believe his name is Walter. Maybe I got it wrong. But this gentleman here does some great 3D prints. He made an air pump. 3D printed air pump. Pumping balloons to play his.
I think we showed
air
this
powered. We
a
did?
couple weeks ago, yeah.
I think we've showed this, but not the air pump. So it's just like an
Oh,
assembly video.
okay,
of it. Yeah.
okay. Yeah, the air pump
Yeah,
we
look at that.
touched on, but I didn't see
Oh.
any video of it.
Yeah. Pretty cool.
Very cool. Check that out.
Last thing, Wintergatan, 3D printed drums, super dope. Love his videos, love his work. Crazy maker guy.
Very cool.
Very, very cool stuff. So check him out as well. Last one. This is
A
cool.
new method
Kirby
of
sent me this
doing
one.
time lapse is really cool. So
Yeah.
he has an end switch on one of the sides where he's printing a perimeter that is activating the camera.
Yeah, it's triggering it after every kind of layer. It's pretty dope. It's really cool. It's like growing and you can't see the tool head. This is a great option for printers that have like a massive tool head that just take up and cover up the entire print.
Yeah.
So some of the dual extruder Cartesian direct drives do that. Kind of like Flash Forge as well does that.
Yeah, they're pretty big.
Yeah, so really cool. Check it out. That's it. We'll have more stuff shared. Oh, I blocked everything. Oops.
Ooh.
Yeah, check that out so you can see the full thing. This is a great way to kind of stop content ID stuff. All right. Coupon code CNC Wood. If you want to pick anything up, support the show, support your maker habit. Yep, the chat is covering up the image. Yeah, I know.
Yeah, we got to work on being able to move it over to one side.
No,
when we're on that.
yeah. I know. I just forget to switch it. I'm still learning. After
What?
2 years, I'm still learning.
What is the benefit to the world for this week? Q&A. 3D printing, what is the benefit to the world? Hopefully
I think AT
teaching.
Makers does a great thing. Prosthetics is a great option as well.
Prosthetics. The overly priced assistive tech that can easily be 3D printed or customized for anybody's specific needs.
Yep.
It's definitely
Great medical applications as well.
Yeah, it's definitely a benefit to the world. And of course, the education side of it, kids learning math and engineering and design and manufacturing and technology, video and production and all that cool stuff. So lots of really good benefits to the world there.
Cool.
Botnet making, how to make a botnet. I think Colin has a tutorial on Bitcoin mining, if I'm not mistaken.
Yep.
What do we think of the new monoprice printers? They're even newer ones than what we saw before? What? Send us a link.
Yeah, we'll take a look at them. Okay, well you guys queue up answers or questions. Later tonight we'll be on the show and tell, and hopefully you folks will join us as well. To join, just go to plus.google. Wait, what is it?
I think you just comment in the video that is starting up for the event.
Yeah, and we'll post the chat link in there, so just go to the YouTube link. Okay, great. Yep. And then Ask Engineer, new products, new news.
Should be a ton of really cool news for this week. Yeah. So be sure to check that out.
Cool.
And of course, all the other videos that are always coming out, check those out. Make sure to subscribe. Some
great new projects coming out from other folks. Aaron St. Blaine, he's got a really awesome new project coming out.
Oh, yeah.
John Park's working on some great stuff. Colin's working on some everybody's working on good stuff. So we thank you guys so much for joining us today. We're going to go ahead and close the show, and we'll be back next week with some cool projects.
Cool.
Yes, I saw that, Simon. He's testing out the palettes and doing a review. That is great.
Sweet.
Looking forward to seeing that.
Right. Yeah, it looks like they were all testing that on the Craft bot, so it should work out pretty well. On the Type A machine and the Replicator 2 and the Flash Forge, I kept getting jams, so I was never able to get any of the splicing to be not bulged out where it would get stuck inside the extruder. So hopefully that works out really good.
Cool. Tech Geeks for You. Is that the person?
Oh, the new Delta
Isaac,
one.
Huh? Isaac is asking where he can share his first project. Yes, please do share it with us. You can hit us up on any of the social channels up here. Always looking for projects to share on the blog, so let us know, and we'll share the project. And if you want to get an As Seen on Show and Tell sticker, that's right. Tune in at 7 p.m. Eastern Time. You could also get don't tell anybody. You could also get a free 3D printing badge. Oh yeah, a skill badge to show that that you have achieved and have learned a new skill. And that's what we do. That's something we don't usually advertise, but a lot of folks get that. It's working for now. Yeah, I was able to get like 2 prints to work, and then it just kept jamming after that. I don't know why. Right? Yeah. I just I don't have time to try to test and make crap work. Yeah. But there we go. All right. Well, thank you guys so much for joining. We'll see you next week again, live on Wednesdays at 11 a.m. every week. Don't forget CNC Wood if you want to pick up anything. New pixels. Those are in stock. Should be there. Joy Bonnet maybe next month. PiGRRL, we'll couple weeks. Know. No, everything gets sold out so quick. Yeah. Thank you all for supporting. Yes. All right, guys. We'll see you later tonight and next week. Bye, everybody.
See you guys.